Hey hackers, welcome to AzefoxInnovations' new video on Server-Side Request Forgery, also known as SSRF. SSRF is a web vulnerability, right? This vulnerability might sound simple at first, but in real-world breaches, SSRF has been the gateway to cloud account takeovers, internal network pivoting, and even remote code executions, right? So let's get started. So what is SSRF, right? So at its core, SSRF occurs when an attacker can control the destination of the server-side request, right? Instead of the server fetching a legitimate resource, it's tricked into fetching something chosen by the attacker, right? The critical issue here is that servers often have more trust and more access than external users, right? For example, a server can talk to local hosts, query databases, connect to APIs on private subnets, or access cloud provider metadata things that attackers normally cannot touch directly, right? So how SSRF works, right? So the mechanics are straightforward. The attacker first submits a crafted input containing a malicious URL, right? The vulnerable application then processes this input. Maybe it's an image fetcher, a PDF converter, or a URL preview feature, right? Whatever it may be, right? The server then issues the request on behalf of the attacker to the internal systems, right? This turns the server into an unwilling proxy, right? Acting as a middleman. The attacker doesn't need direct access to the internal network. The server does the heavy lifting, right? So depending on the application logic, the attacker may see the response directly or just confirm it indirectly, right? So here is a visualization about how an SSRF attack will be performed, right? So we have the attacker here, right? As you know, we have the attacker here. We have the web application, and this is the internal resources, right? So as an attacker, you won't be directly able to access these resources, right? But using the vulnerable application, the application or the website which is vulnerable to SSRF, you can trick the particular server, into acting as a middleman and requesting, the request from the attacker, and forwarding that request on behalf of the attacker towards the internal resources, right? And these type of attacks are like really dangerous and kind of devastating even in real world scenarios, right? So an example scenario here, right? We can take an example of a social media platform that let users fetch profile pictures from a URL, right? A normal user inputs https example.com/avatar.png, right? But an attacker instead supplies localhost admin, right? So the application fetches the internet admin panel, assuming it's just another image. If the application doesn't sanitize or restrict outbound requests, the attacker now has direct visibility into resources never meant to be to be public, right? So yeah. Types of SSRF, right? So there are two primary categories of SSRF. One is the basic SSRF. In this video, we are actually going to focus on the basic one, right? The basic SSRF part, right? We'll explore the blind one in another video in one of the upcoming videos, right? So for a basic SSRF, it means like where the attacker directly sees the server's response. This is the easiest to exploit and the most dangerous since the internal pages and metadata get exposed immediately, right? Then we have the blind SSRF, where the response isn't shown to the attacker. However, attackers can still detect if the request was made. They do this by pointing the server to a control domain and monitoring DNS or HTTP callbacks, right? So generally, blind SSRF is harder to detect during test, but as impactful in real world exploitation, by the way. So the impact or some of the real world impact of SSRF, right? So internal services access, right? As what I said, attackers can query services like databases, run a Redis or Elasticsearch running on private IP ranges, right? Like within the organization. Then we have the cloud metadata theft, right? In AWS or we have this particular metadata, right, or site or a URL, right, where the it can like reveal sensitive credentials, right? If you are able to visit this particular site or if you have access to this particular part, I would say, right? And then we have network pivoting where attackers can map and interact with services behind firewalls by chaining multiple SSRF requests, right? Then we have remote code execution, where some services behind SSRF endpoints accept payloads that can trigger code execution. For example, misconfigured APIs or deserialization endpoints, right? So this is why SSRF is not just a bug bounty favorite, but also a high severity vulnerability in enterprise environments, right? So yeah, a quick demonstration here. So for demonstration, I'm going to use the the PortSwigger SSRF lab. We are going to solve just one lab for this video, and it's like really basic, right? So our lab is getting loaded, and I'm also going to use the burp suit tool here, right? So yeah, so let's go to the lab description and what it says. So as you can see that the lab has a stock check feature which fetches data from an internal system, right? To solve the lab, change the the stock check URL to access the admin interface and at this particular endpoint and delete the user Carlos. Okay. So our task is to escalate our privilege, or like we need to access the admin panel and we need to delete the user Carlos, right? So let me explore it. As what I said, we need to look for a stock check feature, right? So let me click on view details here, and we have a stock check part here, right? So let me turn on my web proxy, and it's like already turned on, right? I'm sorry. Yeah. So let me just turn on the intercept. Let me just click on check stock, and let me forward this, right? And here it is what it's like the behind the scenes, like what's happening here. So let me send this to repeater, right? And as what we have seen in the slides, we'll try with a very basic SSRF payload here, right? We can like run we can supply as HTTP localhost, and let me try to the admin path. We'll try to access the admin panel. So let me send this request, and as you can see, it actually responded us with a 200 OK, right? So let me scroll down a bit and let me see that if we are actually able to access this particular endpoint or not. So as you can see, we have something here called admin panel, which means like we already escalated our privileges to admin, or like we are actually able to access the admin panel, right? And as per the task video, as per the lab or the lab description, we need to delete the user Carlos, right? So we have, okay, so for deleting, we can use this particular thing. It's like more of a payload. So delete username is equal to Carlos, right? So if I send this, it says 302 found. Okay, so let me now turn off my proxy, and let me go back to my and you can see that our lab has been solved, right? So that's how we can actually exploit a basic SSRF vulnerability in real life situation. Of course, there might be multiple defenses being kind of built with the, or kind of integrated with the website or at the particular the input taking part, right? So yeah, so just for the sake of demonstration, I've used an easy lab from PortSwigger Academy. Now we'll shift our focus towards the defense part. So yeah, the mitigation part here, right? So defending against SSRF requires multiple layers of control. First is like, of course, we need a strict input validation where we only allow URLs from trusted domains, right? Use allow list instead of blacklist, since attackers can bypass filters with tricks like DNS rebinding or using alternative IP encodings, right? Then we can disable dangerous features. If our application doesn't really need to fetch URLs, remove the feature entirely, right? Then network segmentation, where we can place application servers in restricted zones where they cannot freely reach internal networks or metadata services, right? Outbound requests should be tightly controlled. Then for cloud specific protections, in AWS, we can enforce the IAMD SV2, which requires session tokens and prevents simple SSRF abuse, right? And in GCP or Azure, we can configure firewall rules and restrict metadata access, right? Then at the end, we have the safe library where we can use SSRF aware HTTP clients that implement security controls like restricted IP ranges and host validation, right? So yeah guys, that's all for this video. We'll catch you all in another new video, right? So until then, bye. And yeah, make sure you follow and subscribe to Azefox Innovations for more informative videos. Bye.